So we need to get this into meters squared, and we have 102 centimeters squared. So what we need to do is we need to use a unit converter, and we need to put our centimeters in the bottom and the meters on the top. 1 meter is going to be equal to 100 centimeters. But remember, it's centimeters squared, so we have to square the whole thing and square the whole thing. And when you do this, please do this on your calculators. You get 0.0102 meters squared. So the last video ran out of space, so I had to cover this up, which is what I did previously, so we're going to do it again. So step number 3 is to calculate that force. Well, if pressure is equal to force over area, and I want to solve for my force, I can just multiply both sides by area. So force is going to be equal to my pressure times area, or area times pressure. And my area is this right here. So this is going to be equal to 0.0102 meters squared. And this is going to be multiplied by the pressure, which is this right here. It's 101,300 Newton meters squared. And then notice that the meters squared cancel, and so we have 0.0102 times 101,300, and this gives us 1,033 newtons. So, meaning it would require a force of 1,033 newtons to pull those things apart. Well, let's see how much is this actually in terms of pounds. So our next step is looking at the weight is equal to the mass times gravity. Fg is equal to m times g. So we want to solve for what's the mass required to pull this apart, or another way of looking at it is these suction cups, how much mass could they actually support if you were hanging from them? So we're going to divide both sides by g. So my mass is going to be equal to the force, which is the 1,033 newtons, divided by g, which is 9.8 meters per second squared. This gives us 105.4 kilograms. Well, what's that in terms of pounds? If I take my 105.4 kilograms and convert this into pounds, kilograms versus pounds, 1 pound is equal to 0.45 kilograms. So if I take this and if I divide by 0.45, I get 234 pounds. Meaning, if this was pushed together with atmospheric pressure pushing from all sides, I would have to be like a severe weightlifter that can lift apart and pull apart this with about 234 pounds of pressure. Well, I'm less than 234 pounds, and I could probably be suspended by all of this. So again, we took a look at the atmospheric pressure pushing in and the area that it was affected on, and from that we're able to calculate the force required to pull it apart and we convert that force into a mass of kilograms, and we can convert that into pounds.